My name is Wiki To, and our paper discusses programmability with a focus on how it can be applied to banking and payments. Programmability is the ability of a system to execute specific tasks based on provided instructions. It is not a new concept. We can trace the first programming language to the 1800s. So why this resurgent interest in programmability? Blockchain. Blockchain is changing how we think of systems interactions and how we enable programmability. In conventional system design, a transaction processor is not designed to process arbitrary code. With blockchain technology and smart contracts, multiple parties can deploy and execute code in a trusted manner on a common platform. This allows the transaction processor to also process arbitrary code and is creating a paradigm shift in designing how systems interact and in programmability. Let's unpack these concepts in the example of a bank and its client. Clients have always had the ability to implement specific logical instructions in the form of software code. Clients build or buy treasury management or ERP systems that are deployed and executed within their environment. These systems then interacts with the bank systems through communication channels like APIs. As the logic is deployed and executed on the client side, we refer to this as client-side programmability. The specific innovation of programmability or programmable payments that we are referring to in this paper is the ability for clients to deploy their logic in the bank systems with the transaction processor in the form of programmable instructions. In this manner, the programmable instructions are deployed as self-contained executable instructions with the bank and can be executed directly by the bank systems without further dependency on the client systems. We hence refer to this as bank-side programmability. We will now use a simple example of target balancing to illustrate the differences. Target balance is a common treasury management technique to maintain a pre-specified balance. In a conventional model, the bank system will trigger off a notification to the client that its account has been debited or credited. The client will then communicate with the bank to ask for its account balances, to which the bank responds with an account report. The client will then apply its logic and perform further calculation within its systems, and finally initiate a payment to move funds to achieve the target balance. As depicted by the arrows in the diagram, there are often multiple messages being exchanged across the systems. With bank-side programmability, the client provides the programmable instruction in an if this, do that format. Here, the client informs the bank that it will perform certain tasks when the trigger conditions are met. In this case, it will be triggered when the account is debited or credited. Once triggered, it will evaluate the relative balances of the accounts and perform the action of transferring funds from the chosen account. A simple example is used here, but the client can layer on further logic, such as checking FX rates and sourcing liquidity in a different currency. This new model of bank-side programmability will provide benefits over client-side programmability on conventional systems, such as improved execution and response time, improved certainty of execution with low chance of failures, improved traceability and auditability, and broadened range of programmability with access to data and event triggers not typically available or transmitted to clients. Details of how these benefits are achieved are further elaborated in the report. We expect programmability to have a profound impact on how businesses are performed today. Rather than the conventional waterfall approach of having a payment process triggered by the completion of a business process, we will now see tighter integration and interweaving of such processes. This will result in efficiency gains for the clients and could eventually allow clients to have their payment instructions performed close to or even after typical bank cutoff time. This is as lower time buffers are required compared to conventional channels. These benefits will be tremendous if we can further extend programmability to enable multi-party, cross-organization automation where programmable instructions by multiple different parties can all interact directly with each other. This concept of composability would support more complex use cases and enable cross-organization automation on an industry level. An immediate use case is the atomic operations of linked instructions, where they either completely succeed or completely fail with no possibility of desynchronized states. We hope this presentation on programmability has been useful for you. Please read the report for further details, including 2 practical case studies with live clients that explains how programmability can change and benefit clients' business and banking processes today. Thank you.